On problem 7, here are the results of the sprinters talked about in problem 6. This problem gives us the results of 8 sprinters who started the sprint with the standing blocks and the 8 sprinters times without the block, so just standing straight up. It says calculate the differences standing minus block. So that means that I'm going to do this minus this column. So it's going to be 6.38 minus 6.2. 0.26. 6.52 minus 6.42. 0.1. 6.09 minus 5.98. 0.11. 6.72 minus 6.8. Negative 0.08. 5.98 minus 5.73. 0.25. 6.27 minus 6.04. 0.23. 6.71 minus 6.55. And I get 0.16. 6.8 minus 6.78. 0.02. Once I get my calculated differences, I then am asked to graph the differences using a dot plot. Well, there again, I have to find my smallest number, which is here, and my biggest number, which is here. So I have to make sure my dot plot goes from negative 0.08 to 0.26. So I'm going to start off with negative 0.1, negative 0.05, and I'm going to count by 0.5s. 0, 0.5, 0.1, 0.15, 0.2, 0.25, 0.3. Now, just plot your points. 0.26, 0.1, 0.11, negative 0.08, 0.25, 0.23, 0.16, 0.02. All right. So that's problem A. Problem B says to calculate and interpret the mean difference. The mean difference is where I add this last column. So add the last column. So I'm going to add 0.26 plus 0.1 plus 0.11 plus negative 0.08 plus 0.25 plus 0.23 plus 0.16 plus 0.02 and hit enter. So you're going to add third column of numbers, and I got 1.05. Then you're going to divide by the number of trials. And that was, I believe, 8. Let's double check. Yep, 8. So 1.05 divided by 8 gives you 0.13. So your mean difference is 0.13. So this means that on average, sprinters ran 0.13 seconds faster when starting from I'm sorry, I messed up. This shouldn't be faster, okay? And here's why. When we're dealing with time, a faster time means you have a smaller number, okay? So because this is a positive 0.13, that means they were actually running slower, okay? So 0.13 seconds slower when starting from a standing position. Okay? So the reason why I had to change the word faster to slower is because when we're dealing with sprinting, a faster time means that you're going to have a smaller number. So because my number was positive, I had to change the word faster to slower. C. Describe how to simulate the distribution of the test statistic. Okay? Have 16 note cards. With each sprinter's time on them. I need to change this smaller. Okay. Shuffle each sprinter's cards with their 2 times together. Randomly assign a time to each section, with the sections being with block or without block. Calculate the mean difference and repeat many times. Okay. So for this problem, if you notice on your study guide, their dot plot was not included, but I passed out the individual little half sheets of the dot plot for you to use. I don't have the dot plot on this paper, but you should have it in front of you. So I'm going to pull up the dot plot from another source. So problem 10 says to briefly describe what information is provided by the dot plot. The information that is provided by the dot plot is that the dot plot shows the possible mean differences that the dot plot shows the possible mean differences in not sprinters, in sprint times between standing and using blocks that could occur just by random chance, assuming that the sprinters had the same ability to run fast with either starting position. Problem E, estimate and interpret the p-value. You also need to use the dot plot for this, okay? So for problem E, you're going to use the number that you got from part B. You're going to use this number right here, 0.13. This is your test statistic. So 0.13. If you go to 0.13 on your dot plot, you're going to count how many points are there or above. So go to 0.13 or above. Your dot plot shows that only 1 point, one trial out of 100 was above 0.13. So that my p-value was 0.01. So because your p-value was 0.01, you can say that assuming the sprinters have the same ability there is a 1% chance that you will get a mean difference. I just abbreviated because I was running out of room to write it. Excuse me. Of sprint time performances at least as big as 0.13 or higher. That's what the interpreted means. Tell me what this number here means. That number means that assuming that the sprinters have the same ability, there is a 1% chance that you will get a mean difference of sprint time performances of at least as big as 0.13 or higher. So based on the p-value, which is 0.01, make an appropriate conclusion. Conclusion means to tell me, do you accept the null or alternative hypothesis? Or, yeah. So, because the p-value is small, so because the p-value is small, we will reject the null hypothesis. So because we rejected the null hypothesis, that means we will accept the alternative hypothesis. So part D says to describe how to redesign this experiment so that the data is unpaired. To redesign this experiment to make sure the data is unpaired, you will randomly assign 4 of the sprinters to run with a starting block and 4 of the sprinters to run from a standing position. One thing that I didn't talk about was the type of errors. There will also be a question on the different types of errors. So I would make a little side note. Errors. If we remember, we made this beautiful chart to help us remember how to determine okay, so if this was reality, and this was our decision, if we, I need another set of rows, said that the true null hypothesis was false, the null hypothesis was true, the null hypothesis was false. Okay, so the first two that you can easily determine would be this one, because if you said that if you decided that the null hypothesis was false, and in reality it was false, you made a correct decision. And then if you decided that the whole null hypothesis was true, and in reality it was true, it was also a correct decision. And I misspelled decision. Decision. Alright. So in order to have a type 1 error occurs when the null hypothesis is rejected. So if you reject the null hypothesis, which means false, so if you reject the null hypothesis, but in reality it was true, it is a type 1 error. A type 2 error occurs that when the null hypothesis is not rejected, so it's accepted, but in reality it is false, you made a type 2 error. So if you reject the null hypothesis, it's a type 1. If you accept the null hypothesis, it's a type 2 error. I suggest you use the remaining of the class period today to study for your benchmarks.